Hello and welcome to our RSP Advanced Training or Remote SIM Provisioning in the M2M ecosystem. My name is Olga Kietla. I'm a Senior Technical Consultant at Comprion, and I have almost 15 years of experience in the smart card area, now working almost 10 years in Comprion. I started to work in the standardization area from the very beginning on the eSIM topic or the EUSSC. I hope you will enjoy the training. And let's dive in. Okay, I assume that you know or you have the basic knowledge of the M2M architecture and you know at least the profile types used in the M2M ecosystem. Because today we will rely on this knowledge and we will talk about the remote SIM provisioning procedures, especially about the download, enable and disable of profiles, deleting and the SMSR change. We'll talk about something else, about the other procedures as well, but maybe less detailed. And the second topic for today is the M2M security and the security aspects. We'll talk about the keys and certificates used in the M2M ecosystem, and we will talk about the algorithms used. Let's start with the procedures. Okay, the M2M procedures used in this area, so mainly the first procedure is the profile download and installation. This procedure goes from the operator to the EUSSC and includes the following parts. First of all, the ISDP creation on the EUSSC has to be performed. Second part is the so-called key establishment or personalization of the ISDP with the first key set. And the last part, yes, this is the download and installation of the profile onto the EUSSC itself. The profile enabling is the second part, so to make the profile working or to make the device being able to make a call. So you have to start with the profile enabling and the operator. This goes from the operator to the SMSR. Optional, it can go from the operator to the SMDP and then can be forwarded to the SMSR. But actually it's the same type of the procedure. And this profile enabling will make the applications and the files within the profile visible and selectable on the EUSSC terminal interface. Other way around, so profile disabling goes again from the operator to the SMSR. Option, it can go via the SMDP. And will make the applications and files within the profile invisible and non-selectable. Okay, if you need to delete the profile, so there is a profile deletion procedure, and it goes from the operator to the SMSR. Option, again, same as for enabling and disabling, can go via SMDP, and is used to delete the target ISDP with its related profile data and applications from the EUSSC. These are the basics. Okay, we have another procedures as well, so especially the master delete goes from the initiator to the EUSSC and initiates the deletion of an orphan profile without the fallback attribute set regardless of the profile's policy rules. Okay, you remember what is the orphan profile? The profile that cannot be used anymore because, for example, some contract has ended. So, and it's not possible to delete this profile in the regular way. So therefore you have this master delete procedure. This can be used for this specific type of the profiles. And again, so the fallback profile, since this is a quite important profile, so this cannot be deleted in this way because otherwise, so we risk the connectivity loss completely. So we can risk that the device is completely dead. And we don't want this, and therefore there is this restriction. Another important procedure is the SMSR change. This goes from one SMSR to another SMSR. And the main part of this procedure is to transfer the specific EUSSC information set from, so for one EUSSC from one SMSR to another. And connected to this is the establishment of a new key set on the SMSR. So SMSR knows about the EUSSCs which are belonging to it. And therefore, so the new key set has to be established in the ISDR, not the ISDP, to ensure secure communication between this new SMSR and the EUSSC. So you will see in the further steps of the process so that the profile will be first encrypted by the SMDP, and then it goes to the SMSR, and the SMSR forwards this to the EUSSC. And for this kind of forwarding, so there is a secure channel used, and therefore, so for this secure channel, the specific key set has to be established. So therefore, this key establishment procedure. Yes, the small but important procedure, so to start with, is the EUSSC registration. This step is used by the EUSSC manufacturer to register the EUSSC information set representing an EUSSC at the SMSR. So that using this EUSSC registration, the SMSR will know this basic information contained in the EUSSC information set. In the EUSSC information set, you have such important things like the profiles and so information about the profiles and the information about especially the certificate information, so which is required for the cryptographic operations. So it will be contained in this EUSSC information set. Okay, yes, then there is this policy update. So you remember there are two types of policies in the M2M, policy 1 and the policy 2. The policy 1 is enforced on the EUSSC, the policy 2 on the SMSR server side. And therefore, the policy 1 update goes from the operator to the EUSSC via ES6 interface. Remember, the ES6 interface is the interface between the operator and the EUSSC, and can be used only when the profile is enabled. So it's using the specific key set from the operator. Therefore, so it requires the enabled profile. So the OTA keys will be used. And the policy 2 update, as I said, so it goes from the operator to the SMSR, and the operator sends the policy 2 directly to the SMSR or through the SMDP to attach them as a metadata to a profile. So policy can be something like, so this profile has to be deleted immediately after the disabling. So this can be this type of policies. Okay, connectivity parameters update. This is a quite important procedure for the M2M because, as you remember, the difference or the specific part of the M2M is that what we have is so the connectivity is always required in the M2M. So the profile cannot be downloaded on any other channel, so despite the regular network channel, so therefore it requires the network connection. Always there should be a network connection to the device or to the EUSSC, and therefore the connectivity parameters are quite important. They can be updated, and this goes as well so from the operator to the EUSSC. They're initiated by the operator on the ES6 interface again. Alternatively, it can go via the SMDP, but then there's some different protocols have to be used because so this is important information. So it's the SCP-03, Secure Channel Protocol 03, is used on the ES8 interface. Okay. The default notification procedure. So there are plenty of notifications in the M2M. And so they can be used sent via SMS, and so they can be sent via SMS or HTTPS, and they go from the EUSSC to this SMSR for this notification default procedure or default notification procedure. But in general, so there are notifications being sent to the server side from the EUSSC just to inform about the status of the profile being enabled, disabled. You will see it in the detailed description. Fallback activation procedure. This goes from the EUSSC to the operator. And by this procedure, so the fallback profile, remember this is the profile which is quite important in the M2M, so to assure the connectivity. The fallback profile is activated in case the currently enabled profile loses network connectivity, or by execution of the disable profile function on another profile. So if you disable a profile, so that it needs to activate another profile, and if you don't select specific profile, so when you just disable, so this is the case, then the fallback profile will be activated. Yes, and the EUSSC shall disable the currently enabled profile and enable the profile with the fallback attribute set. Let's take a look on the profile download procedure, just one by one. We have the operator, the SMDP, SMSR involved in this process. And the information goes over the network and it goes to the M2M device with the EUSSC. Just a simplified version is that there is the ES2 download profile command or request actually. So then there is this on the ES3 from the SMDP to the SMSR. The first, so the SMDP needs to know the information about the EUSSC. Therefore, this get EUSSC information set needs to be sent to the SMSR, and the SMSR responds to this. Then there is the creation of the ISDP. So this will be forwarded to the EUSSC with a return information being sent to the SMDP about the status. And then in the next step, so there can be the establishment of the ISDP key set can be performed. So now picture is used, so it's used with the HTTPS, because this is actually the more often used way to download the profile using the HTTPS because of the big data. It's different, for example, for the enable profile when you have a small command being sent to the EUSSC. So where just a simple SMS makes more sense in this case. And the protocols which are used for this key set establishment are the SCP-03 or 03T for the encryption first of the profile. This is on the ES8 interface. And for the information being secured between the SMSR and the EUSSC is the SCP-80 or SCP-81. Okay, then the final download. So okay, now here you can see the SCP-03 or 03T for the encryption of the profile itself. So being used on this ES8 interface. And again, so the actual encryption between the SMSR and the EUSSC is using the SCP-80 or 81, or SMS HTTPS. As I said, notifications or the status information being sent back, so the profile download completed, and back to the operator. Okay, let's take a look a bit on a bit deeper level. So what is required? The precondition for the profile download is that for sure that the subscriber has to be subscribed to a selected operator. Then the EID, EUSSC ID of the target EUSSC and the ID of the SMSR, they are known to the operator. A profile ordering procedure has been completed with a selected SMDP. So the profile needs to be ordered. And the target EUSSC is integrated into a device and is associated to an SMSR. So the registering information has been already performed. And alternatively, the operator may activate the related subscription in the network by the ICC ID. ICC ID, you remember, this is the ID of the profile. So just little bit deeper. So this is actually the profile download request being sent to the SMDP. And then the SMDP performs the SMSR identification. So the information being sent, just a step back, the information being sent with the profile download request will include the ID of the SMSR. So therefore, the SMDP can perform the SMSR identification. Okay, in the next step, so again, this get USSC information set from this specific SMSR will be performed, and the red line means that there might be some mutual authentication between the SMDP and SMSR if it has not been performed before. Okay, as soon as SMDP receives the USSC information set, so the USSC eligibility check will be performed. So it will check, for example, so the profile size compared to the memory of the USSC. So this is related to the SMDP. So, and the procedures included there. If there are no errors, no issues, then there is the next steps of the ISDP creation. Again here, so there's ISDP creation request, so will be sent from the SMSR to the USSC, and so if there is some mutual authentication required, so then it can be performed. But normally this step has already been performed. The information will be sent back, and actually this key set establishment is performed between the SMDP and the USSC. So the SMSR and the device, the HS forwarding. And the HTTP post encryption, so is between the SMSR and the USSC. If everything went fine, so the key set has been established. So this is the specific symmetric key set, which will be established. And the specific key set will be used to encrypt the profile. Therefore, the profile selection can be done on the SMDP. Profile will be encrypted, so the secure channel will be established using this new derived key set. And then the actual download and installation can be performed. There is an information being sent back. Then also an update from the SMDP to the SMSR about their profile installation result. So if that has been successful, so the content of the profile will be set to the profile has been downloaded. And the download profile confirmation will be sent to the operator. Again, we have here the SCP-03 and 03T protocols together with the SCP-80 and 81. So they kind of a double encryption. So last time I compared this with two envelopes. So if you put the profile actually itself in one envelope and then put this envelope in another envelope. This is the kind of encryption being performed here. Next step is the enabling of the profile. Okay, we have this old MNO, which we want to leave, and the new operator, which we want to switch to. We have the SMSR and the two types of networks. So the old network and the new network. And the USSC itself for sure. Okay, first of all, the new MNO requests to enable the profile. This may be also triggered via SMDP. Then the SMDP will be somewhere in the middle. So yes, kind of here. So between the MNO, it goes first to the SMDP and then to the SMSR. But it would be actually almost the same command, but being sent on the other interface. Yes, so it would be ES2 enabled profiles being sent to the SMDP, and then it would be sent the ES3 enabled profile to the SMSR. Actually. Then there is a store data command. So this is actually the store data command being sent from the SMSR to the USSC. So data definition, this type of commands as defined by global platform. And so it should contain the ISDP AID, application ID. So if you're requiring the deeper knowledge how it works with the installation, so please take a look on the global platform card specifications. So in the GSMA specifications, there is a definition of this as well, but the deeper knowledge can be gained from the global platform card specifications. Okay, as soon as the EUSSC receives this command, it's checking the policy 1. So if there is possible at all to enable this profile, and sends a refresh to the, so from the EUSSC to the terminal baseband to connect to this new network you see. So this is this has been sent using this old network, and as soon as the terminal receives to the refresh command, it is attaching to the new network. And the next step, so the handle notification confirmation will be sent back to the SMSR. And depending on the policy 1 and the fallback attribute, the disabled profile may not be deleted. Sometimes the policies are requiring so to delete this profile, so sometimes not. So the disabled profile, so in the regular case, so it will be not deleted, just disabled. But the EUSSC information set will be updated, so saying, okay, this profile is now in the enabled state. Okay, and the SMSR may check the policy 2, especially for this deleting. So if it is required by this policy 2, so then so this delete command will be sent. Again, this delete command defined in GSMA specification, global platform specifications. Yes, and same for the response. If in the first case, the enabled profile has been sent via SMDP, so it goes back again, so via SMDP with this information about the result of the profile enabling. And the notification about profile disabled status, so meaning the old profile has been disabled, has to be sent to the old operator. Okay, let's go to the next procedure, the disabling of the profile. This is almost the same from the steps, so but it goes now, so we have the MNO with a fallback profile. This is the regular case, the MNO with a fallback profile is required because we always need a profile being enabled. And the current MNO, also the actually enabled MNO, the SMSR, we use this network of the fallback, of the profile of the operator to whom belongs this profile with this fallback attribute set, and the network, so which is a current network, and the EUSSC with the device for sure. First step, so the current MNO is requiring the disabling of the profile. Also, the MNO is who is using this profile. And again, so this procedure may also be triggered via the SMDP. In this case, the current MNO sends first to the disable profile command to, or the function command to the SMDP, and the SMDP forwards this to the SMSR. And then again, there is the store data command, but with a different flag set on this command. So they're going from the SMSR using the current network to the EUSSC. And especially again, the policy 1 will be checked on the EUSSC. And so just to check if it's possible to disable the profile. And the enable fallback profile will be required as well. So there are 3 steps in this case, not only the policy 1 check and the refresh. And this enabling will be performed. This is not visible. After the refresh, the device attaches to the fallback network. And then the handle notification confirmation will be sent to the SMSR. The EUSSC information set will be updated on the SMSR. And depending on the policy 1 and fallback attribute, the disabled profile may be deleted or not. The SMSR checks the policy 2 and might send in the next steps of the delete command to the device of the EUSSC. And as well, again, depending on the procedure, so the disabled profile result will be sent back to the current MNO and might go through the SMDP on the same way how it came to the SMSR, so in the same way it goes back. And then to the fallback attributes, the profile, so to the MNO with the fallback attribute, or with the profile having this fallback attribute, the handle profile enable notification will be sent. The next step is the delete command. The delete command is, so the delete procedure goes from the operator to the SMSR and then to the network and then to the EUSSC end device. Again, can be triggered via SMDP. In the next step after receiving this delete profile command, the SMSR will verify the policy 2 and the state of the profile. If the profile isn't enabled a state, so then it has to be disabled first. So if everything goes fine, so then the delete command will be sent to the EUSSC. The policy 1 will be checked, and if it's all okay, so then it will be positive response back being sent to the SMSR. And the EUSSC information set will be updated. Finally, the delete profile result will be sent to the operator in the same way how it came to the SMSR. Let's go to the more difficult procedure, the SMSR change. This procedure has to be performed, especially so there are some maybe some business agreements has been changed, some changes in the process. So there are some backgrounds which are outside of the SMDP specification. Sorry, not SMDP specification. There are procedures which are outside of SGP technical specifications, and these procedures might require this SMSR change procedure. Okay. The MNO SMDP, so to whom belongs the SMDP, and the MNO and the initiator MNO are involved in this. And let's talk about the SMSR old and the SMSR new. They are communicating via network, with the device and the EUSSC. So first step, so from the initiating MNO, so there is this prepare SMSR change procedure being sent to the new SMSR. With this SMSR change procedure, so after receiving this response, so the actual SMSR change will be started. Going first to the old SMSR, because the old SMSR knows about this, the keys and the data of the EUSSC. The next step, so this old SMSR sends to this new SMSR the commands on the ES7 interface to hand over the EUSSC information set. Hand over EUSSC with the EUSSC information set. The EUSSC information set, as you remember, contains the certificate of the EUSSC, or the ECASD certificate. And this certificate will be, so at least the certificate will be known then to the SMSR, which is quite important. So because then it can be used for the cryptographic parts. And the authenticate SMSR command being sent to the old SMSR. There is an authentication between these SMSRs. Then the established key set, ISDR key set, will be performed between the old SMSR and the new, and the EUSSC, if it has not been performed before. So verifying the, so for this part, so it was used to verify the certificate of the SMSR. And then in the next step, so this is the authenticate SMSR success information will be sent to the new SMSR. So the EUSSC checks, so first of all, in this first step, authenticate SMSR sends its own certificate back to the old SMSR. So and this certificate will be sent to the EUSSC to verify the certificate, to be verified by the EUSSC. If it's successful, then so the information about this will be sent to the new SMSR, and the new SMSR is happy. But they need its own key set, and this part will be performed using the old SMSR. Therefore, the key as the create additional key set will be sent to the old SMSR with the ephemeral public key and also of the new SMSR. Then there is actually the establish ISTR key set with this new ephemeral key will be sent. So actually new from this new SMSR. And the setup of a secure channel can be performed. And the final step is the finalized ISTR handover. There is an update of this EUSSC information set will be sent to the old SMSR, and the EUSSC information set will be deleted from the old SMSR. And finally, so there is a handle SMSR change notification will be sent to the involved SMDPs, or actually the operator to whom belongs the SMDPs. Okay, it's quite complex, important to understand, so that this establishment of the new key set is performed using the old SMSR, not just on its own with this only new SMSR. This was the most difficult part. Let's talk a little bit about the local functions. These are new functions related to the version 4, and so yes, 4.0, 4.1, 4.2 or later versions, so of the SGP specifications. These are functions, functions of the interface between a device and an EUSSC that provides the capability for a device to locally enable and disable the emergency and test profile. So it's used only for the emergency or test profile on the EUSSC without the involvement of the SMSR or SMDP. So the procedures for enabling and disabling will look completely different, because it's only local and only for this specific case. So you remember this emergency flow profile is used, for example, for the emergency call. And yes, so this can be enabled and disabled. So in this urgent case can be used, so this specific local functions. The support of these functions is optional, only for emergency and test profiles. And just to add on, the EUSSC shall not send a report to the SMSR when a profile has been enabled using this local enable functions. That would irritate the SMSR, the regular process and the status. In case the execution of the local disable fails, for example, the previously enabled profile deleted and previously enabled profile not providing network connectivity, the EUSSC shall trigger their fallback mechanism. Otherwise, it has to come back to, so the plan is that next it comes back to the previously enabled profile. And the triggering of this function is not defined. It's just forbidden to trigger this remotely. So let's take a look, just simplified version of this local enable and disable on the example of the test profile. Okay, we have, so for the enable, so the local enable test profile goes from the device to the EUSSC. The EUSSC verifies that the target profile is a test profile. So in case of the failure, it has come back, and then verifying so that the current enabled profile is not an emergency profile, and so enable the test profile. So it cannot be the same type. So same time the test and emergency profile. And local enable test profile response will be sent to the device. Then it requires a refresh, so just to reconnect to the network. And the network attachment with the enabled profile will be performed. Same procedure other way around. So for the disable, we have a local disable the test profile, verifying that the current enabled profile is not the emergency profile. And so then the disable, so we're disabling the test profile, checking that it has no other flags actually. Okay, and as I said already, so this part in this case it's disabling the test profile and enable the previously enabled profile, not the fallback profile. unless there is some connectivity loss. Then there is the refresh again, the USSC reset command, so being sent with a refresh, and network attachment to the enabled profile, with the enabled profile. Okay, that's all for the local enable and disable. Let's talk a little bit about these new functions, and so which came in with a version 4 into the specification. This is the Profile Lifecycle Management Authorization, or the PLMA. This is actually, the PLMA is a combination of managed identifiers and authorized actions. The PLMA functions cover the setting, unsetting, and status inquiry of the PLMA in the SMSR, which are initiated by the operator. And the operator can manage the PLMA for its own profiles through dedicated operator SMSR interface, which is the ES4A, and the operator SMDP interfaces on the ES2. Using these new functions of the get PLMA and set PLMA. And especially this mechanism allows the operator or the profile owner to grant authorization to an M2M service provider to permit the profile lifecycle management. This includes the allowance to perform certain operations and receive certain notifications related to a set of profiles identified by the profile type. Here we have the list of possible actions: get or audit the USC information set, the enabling, disabling, or deleting the profile, set or unset emergency or fallback profile attribute, and handling of notifications. For the profile lifecycle management authorization, so there is some data which is included in this. So just to see what is important to be known is the first of all, the operator ID, so the identification of the owner of the profile. Then the profile type of the profiles concerned by this PLMA. So it's meaningful, this string, so this is just an information which is meaningful only in the content of a given operator. Okay, if it is empty, then the profile, so it means that all profiles owned by the operator identified by this specific MNO ID have an empty profile type or no profile type in the EUSC information set. Okay. The identifier of the M2M service provider is the next information. And then there are this authorized operations, which I mentioned just before. This is the list of operations named, and so they are named there. And yes, they are. So this is the information which allows to identify what is possible, what is the authorized action. And if this list is empty, so it means that no operation is allowed. Another new function is the operator notifications configuration, so the ONC. Again, a combination of identifiers and discarded notifications. Operator can manage the ONC of its own profiles through dedicated operator SMSR and operator SMDP interfaces. ONC mechanism allows the operator to define if and which notification should be received for a dedicated set of profiles, whenever the status of the profiles has changed, whatever the origin of the status change is. So for those of you who are familiar with the consumer device specification, this is kind of a similar functionality which has been already included in the consumer world. So you can you have the chance to change, so to inform as the specific to inform about the specific status of the profile, for example. Yes, and the support is optional. So if the SMSR supports this functionality, it shall have implement the functions which are called set ONC and get ONC of the off-card interfaces. The last point is that if the SMSR does not support this functionality, it shall not accept calls to set ONC and send notifications to the operator as if the operator has not set an ONC. Okay, that's all. For the next step, we will have the attribute management, which has been more detailed in this newer versions of the specification, especially for this emergency profile is completely new. You might be knowing so that it's different. So one of the difference between the consumer devices and the M2M devices is that it's not possible in the M2M to inform about the type of the profile compared to the consumer worlds where you have the specific flag identifying the profile. Here in this case, so we just download the profile and then the specific attribute has to be assigned to the this profile. Yes, and yes, the attributes are used for the emergency and fallback profiles. The attribute management for emergency profiles distinguishes between the two different cases when attributes need to be set to a profile. So for this emergency case, it's case 1, setting the emergency profile attribute for a profile when no other profile has the emergency profile attribute set. This kind of first assignment. And the second case is performing a change regarding the profile that has the emergency profile attribute set. For the sufficient assignment of the emergency profile attribute, it has to be verified that the profile shall be assigned, so the target profile, so let's say it has not set a fallback attribute, so it cannot be the same at the same time emergency and fallback. To set or to respectively unset the attribute, sufficient authorizations required, so the PLMA needs to be used. And notifications about the attribute settings are sent in accordance to the ONC if it's supported. Okay, next step is the attribute management for the fallback profile. It's a little bit different. The fallback attribute cannot be set on a profile if its policy 1 contains the rule profile has to be deleted. So the deletion is mandatory when the state changes to the disabled. So you remember, disabled then delete. So it cannot be used. So the profile, so the PLMA, profile lifecycle management authorizations required for this setting and unsetting. And notifications about the attribute setting are sent in accordance to the ONC. Please note, actually, there is no operation that explicitly unsets the fallback attribute on the profile, because the fallback profile attribute is only unset and as a consequence of setting the fallback attribute to another profile. So you will not find these functions. Okay, let's take a look on some other procedures. So just briefly, because they may be less used or so less complex, and it's just sufficient to mention these procedures. Okay, this is complex but less used, the master delete. So this is not allowed for the profiles with a fallback attribute, and it works in a way that the initiator sends a request to the SMSR. The SMSR requests authorization from SNDP and the operator before sending the master delete command with authorization token to be verified by the ISDP. Okay, so regarding this concept of authorization tokens and so on, so please refer as well to the global platform specification. And just to mention, the master delete is at least for the moment it's not tested on the on the card side. So therefore, it's yes, it's you can see how far is used. Yes, the fallback activation procedure is initiated by the EUSSC or the ISDR and followed by the refresh and the reattach. So it's always the case. We've seen this partially included in some other procedures. Yes, and there's another procedure. This is a so-called rollback procedure. It's a bit different than the fallback because it's about the connectivity loss or the connectivity failure. It's not the connectivity loss. It's happening or while enabling And so it happens when the profile, which is trying to be enabled, you try to enable a new profile, and then something goes wrong. So this profile is not enabled at all. Then the procedure is for rolling back to the previously enabled profile. So yes, and this will be again followed by the refresh and reattach. So it's something like nothing happened because it didn't work to enable a new profile. Just to mention the notifications. Notifications are applicable either for first power on of the device, for the enabling of a profile after explicit request or fallback mechanism. They may happen using SMS or HTTPS. Yes, and certain control over notifications is given to the operator using this ONC function. Okay, now we went through almost all of the procedures. So in the general overflow and yes, going deeper in some other procedures, let's go to the summary or just to the check. So this is the point where you can verify your knowledge. So there's just a few questions just to check if you paid attention, and if you know the answers, then you're good. If not, then you have probably to take a look again on the process, on the descriptions, and refresh this in your mind. The questions. What are the main steps of the profile download procedure? Please remember, so there are the kind of 3 main steps, which were in the first slides, or yes, in the description. What is specific for... Okay, hier muss man das ausschneiden. Hier meldet sich der Baramundi.
Kein Thema.
So the next question is, what is specific for the local enable and disable? So you remember there are some local functions. What is so different for this compared to the remote or the classic enable disable in the M2M ecosystem? What is the PLMA? The process of last mentioned amendment or whatever. There are plenty of ideas. You can decide what it is, or you can take a look back. Same for the ONC. Take a look back, so I don't start with my suggestions. So no, just joking. So please refer back to the previous slides. How can attribute management be performed? So you remember there are different types of attribute management. So for the emergency profiles and for the test profiles, what is specific for this? And please remember, so that for the test profile, it's called the flag, not the attribute, what is being set. And the procedures for the attribute management is not related to this test profiles. Okay. Now I say goodbye for the moment. So you can take a first break for this and refresh everything in your mind, because in the next step we will go to the security aspects, the keys, certificates, and the algorithms. You need a deeper breath before we start with this topic. Okay? Goodbye.